Students, this is Unit 2, Segments, Lines, and Angles, Lesson 2.2, Congruent Angles. Make sure you get a date, time, location. Review. You have angle JKL and LKM are a linear pair of angles. The measure of angle JKL is 5x, and the measure of angle LKM is 14x minus 10. Find everything possible. Press pause, complete, restart when finished. Don't just copy. Pause. Welcome back. Our goal here is to draw a label list, cross out. First off, we have JKL and LKM are linear pair. Linear means share a spine, pair, make a line. So I'm going to start. I know my end product has to be aligned. Why? Because of that word linear. And pair means two angles. So I have two angles that make a line. You take a very close look. You should have noticed that KL and LK is the common ray here. So that means that that is going to be the middle hinge. So I have J, K, L. I'm going to do that one in blue. J, K, L, which is 5x. And then LKM, LK, and then this would have to be M here. And that's going to be 14. X minus 10. Find everything possible. Because we share spine, make a line, it means we add up to 180 here. So I know that 5x plus 14x minus 10 equals 180. You collect like terms. I have 19x minus 10 equals 180. Add 10 both sides. 19x equals 190. Divide by 19. We get x equals 10. Woohoo! You think you're done? No, of course not. Hopefully you're starting to get that by now. So 5 times 10, that's going to be 50. And then 14 times 10 is 140. Minus 10, that makes it 130. Here's your check. There's 50 and 130 add up to 180, and the answer is yes. So today, last class we talked about different pairs of angles, complementary, supplementary, linear pairs, vertical angles, and adjacent angles. I'd like you to read this out loud. By the time we're done, we're going to talk about this. Congruent angles, bisect, vertical angles, give and improve, complementary, supplementary. So we're going to talk about in what circumstance do we get angles that are equal? Before we go on, let's review our pairs here, our pairs. I'm going to pause here just for 30 seconds. I'd like you to, as quick as you can, draw an example of each of these pairs of angles. Go. Let's see how you did. Adjacent just means two angles that are back-to-back, share a spine. Back-to-back, share a spine. So this blue angle here, this green angle here, they share a spine, also known as a common ray. That would be adjacent. Complementary, complementary means sum 180. So that's two angles that have to add up, complementary sums 90 degrees. So that's two angles that add up to 90. So this green angle and this pink angle are both adjacent. They share a spine and they're complementary. They add up to 90 degrees. Vertical angles, by far the easiest to spot, but also the easiest to overlook. Two straight lines, the angles directly across from each other, and they're always going to be congruent. linear pair, supplementary, linear means line, pair means two. So share a spine, make a line. This red angle and this green angle are both supplementary, which means they add up to 180, and they're linear pair, they make a line. All of those are pairs of angles from the previous class. Now we're going to learn the difference between these two. We're going to draw an angle PQR with an interior ray QT. Use your pencil. I'm going to wait 10 seconds here. I want you to try to draw that as quick as you can. Go. Okay, we have an angle. Doesn't matter what the angle size is. I don't tell you whether it's acute or obtuse. But it's PQR. Q must be the vertex or the hinge, if you will. P, Q, and R. Says with an interior ray. That means a ray, there's Q again, starts at Q, T. Now, I do not tell you it's in the middle. It's just inside the angle. So offset it a bit, or it should be offsetted. Never put a interior ray right in the middle unless you're told it's specifically a bisector. On that note, I'd like you to take a shot at drawing this. I'll give you 10 seconds. Once again, I don't tell you whether or not it's obtuse or acute. It doesn't matter. It's PQR again. Q is the hinge, PQ and R. But what does matter is I tell you specifically it's a bisector, which means in this angle, that ray must go right down the middle, just like a midpoint or point and a segment. QT, and just like in a midpoint, you don't have a midpoint unless you have hatch marks. You do not have a bisector unless you have hatch marks. Now that's a bisector. Ready? You try. Read this, draw it, restart. Welcome back. Let's take this one step at a time. It says draw an obtuse angle, HIJ. So I'm going to draw an obtuse angle. Obtuse means bigger than 90. I has to be the hinge because it's in the middle, the vertex, if you will. That's H, I, and J. Doesn't matter whether H and J, those can be swapped. Has an angle bisector, IK. So in the mouth of this angle, it's being exactly cut in half by IK. We're going to trace and sweep HIK. So here's HIK, trace and sweep. Oops, forgot to add the K there. Trace and sweep HIK, so you should have traced and swept HIK. And we're going to draw a bisector of HIK, and that's going to be ray IL. So once again, right down the middle. IL, then you cut that orange angle in half. Double hatch because it's your second set. Compare that to what you've drawn. Make note of what you drew correctly or maybe a little off and what you need to remember next time. So now we have two scenarios of adjacent angles, two of them. We have an adjacent angle in which you do not have a bisector, they're just adjacent, they're just next to each other. And then you have a scenario in which it goes right down the middle. You have a bisector. Now in this case, be very careful. When you don't have a bisector, what you can do is you could say little angle, When you don't have a bisector, you can say smaller angles add up to the big one. Little angle plus little angle equals the big one. Red plus green equals blue. When you have a bisector, this is still true. Little angles do add up to bigger angles, but we can also say this specifically about bisectors, is the fact that one angle equals the other one. Why? Because that's the very definition of a bisector, is it cuts angles in half. So watch out for that scenario. When you see a bisector, we can say angles equal to angle. If you don't have a bisector, you're most likely going to be over here. Let's do an example together. We're going to draw an angle EFG bisected by a ray FR. So let's take this one step at a time. We have EFG bisected, underline the word bisected, FR. Notice that F is twice. That means that is the hinge right there. I'm going to start by drawing this. EFG, and it's being bisected specifically by a ray FR. We are told that EFG, careful here, EFG is 15x plus 6. EFG, that's the whole thing, is 15x plus 6. And RFG is 10x minus 32. Find everything possible. Now, it's really, 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 really important here that you learn to think in terms of things before you think in terms of angles. That's where colors come in handy here. Okay, so let's go ahead, pull in a third color here. Let's see what's true here. What's true is that little green angle plus the little green angle equals the big blue angle, right? That's true. What's also true because of the bisector is that little green angle equals, the light green equals the dark green angle. That's also true. So always ask yourself what is true according to the diagram, and when you think what's true, think in terms of things. So here we see the problem is we can't really use this because there's nothing there. So let's see what we can do. This angle, 10x minus 32. And then over here, blue, this is 15x plus 6. The problem is we don't have anything for this light green. But wait, we do. Because the light green is the same as the dark green. Looky there. Always ask yourself what you do know. Don't allow yourself to get bullied by a problem. I don't know what to do, and you just kind of curl up in this passive little ball. Don't do that. Just head it straight on and ask yourself what you can do. Let's collect like terms. Now you're going to solve. X equals 14. Now, very important, you don't just stop at X. What can we do? We can plug it in. Right here, we can go 10 times 14, which is 140. minus 32 equals 108. That means this is 108, not 180, 108. Obviously, this isn't drawn to scale. And then this would be 20216. I don't think you're ready to do something by yourself, so let's do this one together. Ready? It says, draw an obtuse angle PIT with a bisected ray IM. So an obtuse angle. Obtuse means bigger than 180. Excuse me, bigger than 90. I has to be your hinge. With the ray, and it's bisected IM. Take this and go right down the middle. Now, as you draw stuff, cross it out. Get in the habit of doing that. That way your brain says, I've got something accomplished. The measure of angle PIM, trace, P, IM, trace, please. And the measure of angle MIT, trace M, put your pencil on M. Actually put your pencil on your paper, please. IT. It's 4x plus 31. Trace and sweep, note all congruent, find everything possible. Well, we know that these two angles are equal, so we can easily do this. And you simply solve for x. Remember, don't get all happy. Once you solve for x, you want to plug it back in and check it out. So we're going to take that 13 and we're going to put it right there and right there. So we're going to go 6 times 13. And that's going to be 78 plus 5. Going to be 83. Let's check this out. 4 times 13. It's going to be 52 plus 31, also 83. There's your check. Okay, so the one way we've learned so far that angles can be congruent is by the word bisect. But I'm going to be introducing you several other ways that get angles congruent. A few of these we already know. Let's start with the most common. Go ahead and draw 2 angles. Let's pretend they're both 60 degrees. So just put this, draw it by hand to go fast, 60 degrees. So the simplest one is if angles have equal measure, then they're congruent. That's basically what we consider the definition. Just write the word definition. That is the definition of congruent angles, equal measure. If angles are right angles, of course, they're congruent because that means they're equal measure. So some of this stuff is pretty common sense. If an angle's been bisected, of course, you have congruent angles. That's the definition of bisector. A bisector goes right down the middle, therefore making congruent angles. Sweep the vertical angles in two different colors here. Whenever you have two straight lines, of course I call these cat whisker angles, bow tie angles, and for you Star Wars fans, think of an X-Wing fighter. But vertical angles are always congruent. This is by far the most common that you're going to see in the coming months. Make sure you don't overlook those vertical angles. Say I have three different angles here. And angle 1 is congruent to angle 2. And angle 2 is congruent to angle 3. That means we can transfer congruency from angle 1 to 3. In this case, therefore, angle 1 is congruent to angle 3. And the property that that's called is transitive. Transitive. We transfer congruency. Again, this says angle 1 is congruent to angle 2. And angle 2 is congruent to 3. Therefore, 1 is congruent to 3. You transfer congruency. That's called transitive. Ready? I'd like you to pause and try to fill out this page without looking back. Okay, welcome back. Ready? What are the ways so far angles can be congruent? One, if they have the same measure. If those angles are right angles. If the angle's been bisected. If the angles are vertical. If the angles are transitive. Let's pull it all together. We're going to mark this information on the diagram. Very carefully, pulling it all together. In the figure below, trace and sweep angle FCR. I'm going to use red. If you can stay with the same colors with me, that would be good. FCR. So let's just trace and sweep. FCR. Trace and sweep. And angle PCZ. PCZ. Trace and sweep. Trace this segment RZ. Physically trace it. And FP, physically trace it. Trace those segments again. RZ, physically trace it. And FP. We're done with that. Angles FCR and PCZ are vertical. Mark appropriately. These angles are vertical, which means they are congruent. So this red angle and this green angle are congruent. Why? Because they're vertical. They're bow tie angles. Trace and sweep ACF. So ACF. Trace and sweep ACF. Trace. See that word trace over and over again. That's because you're going to think through your fingertips. And if you're not drawing on the diagram right now, your brain literally will not comprehend what's going on. You are not using your eyeballs to grasp this. You're using your fingertips. That's why we're tracing. So we trace ACF. Now we trace the ray CR. And ray CR bisects ACF. So we know this is going to be true. It's going to cut this in half. That's your second set of angles that are congruent. Okay, so look at what you have here. You have some vertical angles that are congruent. See these vertical angles right there? And you have some bisected angles here and here. So the question is this, and notice this is a you do. I will not fill this out for you. You need to think this through yourself, and I will be checking for this on your preview notes. You need to explain, given this scenario, given these three things are true. These three things are true. Given that this was true, and this was true. So make sure you reference all three of these. If you know those three things are true, I want you to explain, how do you know PCZ, that's this green angle, is congruent to ACR, which is right here, that's going to be our purple angle. How do you know, given those three things up top, how do you know those are equal? I expect at least 2 to 3 sentences here. And you must come up with your own writing and your own explanation. Talk it through first. Talk first, then write.